The time has come to talk about covalent bonds. These are going to be formed by the sharing of electrons in order to reach that stable octet of electrons in the outer shell. And one way to draw these is to draw, for example, with hydrogen. Well, first of all, let's look at what it is that each of these atoms require. If this hydrogen atom had one more electron, it would look like helium, so it would have a stable configuration of electrons. Carbon could take on 4 more electrons, oxygen could take 2, and chlorine is just 1 electron away from having an octet. So one way to illustrate this is, in the case of hydrogen, to draw another hydrogen atom with its outer energy level overlapping this one that's already drawn here. And since there's only one energy level, here comes an energy level from the second hydrogen atom. Hey, that's actually not too bad. And here is the nucleus of that hydrogen atom, and it's 1 proton. So I could say that this electron down here, I could draw that one here. That would be the place where I want to try to illustrate that that electron is being shared with this other hydrogen. And then I could say, all right, here in green is the hydrogen atom, this one here, its electron. And so what I want to draw is what's called a Lewis structure. I illustrate that pair of electrons as a line which represents a single covalent bond. And these are very strong bonds. Unlike the bond of ionic compounds, they don't come apart quite as easily as ionic bonds do in water. They don't come apart. Now, to draw a Lewis structure, all I really want is the outer layer of electrons. Those we sometimes call the valence shell electrons. I know I haven't used that word yet, but that's what these 6 electrons or 7 electrons represent. And so in this drawing that I'm going to make, I'm going to take all of the other things, the inner shell electrons and the nucleus with its protons and neutrons and all of that, and I'm going to say that all of that exists in the chemical symbol. So each of these, carbon, oxygen, and chlorine, each of these symbols, again, represent everything except the valence shell electrons. And so the Lewis structure, they're sometimes called Lewis dot structures. For hydrogen, looks like that, right? The H symbolizes the nucleus, and the dot symbolizes the electron. Carbon has 4 outer or valence shell electrons. Here we go. This is the Lewis structure for a carbon atom. The Lewis structure for an oxygen atom has 6 electrons. I like to draw 1 on each side, and then go back with number 5 and number 6 and draw paired electrons. Chlorine has 7, so 1, 2, 3, 4, 5, 6, 7. So all but 1 of chlorine's electrons are paired. It has 1 unpaired electron. And so that actually tells us that chlorine is only going to form 1 covalent bond because it has only 1 unpaired electron. And look what oxygen will do. It has 2 that are paired already, so oxygen will form 2 covalent bonds. Carbon is a very special case because it can form 4 covalent bonds. So let's see if I can draw an example of a carbon compound, what I'm going to do is I'm going to draw a hydrogen here. That's easy enough. Hydrogen has one electron. Here's another hydrogen. That's one electron. A third hydrogen and a fourth hydrogen. Each one brought in its own electron. So now a typical way to look at these is to say, now, can I account for a full complement of electrons around each of the atoms? Remember hydrogen, if it has two electrons, it's good to go. It has it, doesn't it? And I'm running out of colors here to make my points. Carbon, can I circle 8 electrons around carbon? And indeed I can. 2, 4, 6, 8. That means that carbon has a stable octet of electrons around them. It doesn't have complete ownership of them like an ion would, but it shares them. So I could draw the proper Lewis structure for this. Takes those shared pairs of electrons and draws them like so, where this line, again, is a single covalent bond. And the molecular formula for this is CH4. That happens to be methane. Let's see what oxygen can do. Now, I've been looking at single covalent bonds. What if I draw oxygen, and instead of drawing these two electrons here as if they're solitary electrons, what if I pair them up? You don't have to do these, so don't panic. I'm just trying to illustrate covalent bonds. And then I'm going to change colors so that I have another oxygen. And I do the same thing. I'm going to take its non-bonding pairs and then here. All right, now let's see if I can make sense of this. So what I've done is I've shared, instead of one pair of electrons, I've shared two, and I have 1, 2, 4, 6, 8 electrons around that oxygen atom, and I have, watch, 2, 4, 6, 8 electrons around that oxygen atom. And so I draw this Lewis structure as, let's see, I still have these, what we call non-bonding pairs out here, but watch. Each line there represents a shared pair of electrons. So these oxygen atoms are bound together by what is called a double covalent bond. Again, you won't have to draw Lewis structures. I'm just trying to show you how these guys share electrons. Here's another one. What is that? That is carbon dioxide. So all of these things that I've drawn are covalent bonds. And unlike ionic compounds, when they're put in water, covalent bonds are stronger than ionic bonds. They are not pulled apart by water. And so these molecules, which is what these things are called, molecules are held together by covalent bonds. They don't dissociate in water in the same way that ionic compounds do.